How many of y'all are pretty local here to West Texas? Okay, it's about half and half. I was talking to a person in the tent over there that said, irrigation, I'm from Missouri, we don't understand irrigation when it comes to these forage crops and comes to, especially to dairies, so everything's rain fed. Well, the heart of our cropping systems here in West Texas is the irrigation system. The water is what allows it to even be feasible, especially on the magnitude of what a dairy and these feedlot operations require. This is a good station to look at because it's also got the source where we get our water from demonstrated here. This is how we pump most of the water here in the West Texas area, especially in the High Plains area, through irrigation motors with a 90-degree gear head and a pump that goes down into the Ogallala Aquifer that extracts that water out to deliver it to the crops. We'll talk about that a little bit more in detail here in a second. I'm going to give a little bit more of an overview. Most of the crops that are involved in this forage system are these forage type crops, to include different types of sorghums from grain to forage sorghums, corn from, again, grain corn to forage or green chopped silage corn. There's wheat crops, there's triticale crops, and in some cases here we've got alfalfa crops also that contribute. In some other dairy sectors, alfalfa would be a more predominant crop where more water is available, but here where we're pumping out of the Ogallala, that water is a limited resource, and therefore we try to use crops that are going to get us more forage for less water applied. So a lot of the alfalfa that comes into these dairies is sourced from outside of this area or even outside of the state. The crop water demands are variable for all of those crops. They range from anywhere from 24 inches of water per season up to near 40 inches of water per season. In this area we get about 18 inches of rainfall, and we can accumulate that in the soil in the off season or as it comes down on the ground during the season. And the difference between what we receive in rainfall is made up with irrigation. So for example, the wheat crops that we speak of, it's going to have an irrigation requirement of approximately 10 acre inches across the entire crop to get a suitable crop that can be taken to harvest. The corn will go up to, say, 24 inches, the alfalfa upwards near 30 inches of an irrigation requirement in this area. And the sorghum falls there between the corn and the wheat, somewhere in the range of 16 to 18 inches to get a fully matured crop to harvest. To talk a little bit about this dairy-specific irrigation system, there's two real needs to have this system on a dairy. One is to provide the crop to go back as the feedstock for this dairy. The other is that dairies use a lot of water in the process of producing that milk. They use water for wash, they use water for other processes, and therefore have a lot of runoff water that has to be disposed of responsibly. Well, this is one of the ways that it's disposed of properly, is going back through the irrigation system and land applied across the field. That produces some great benefits in that it allows the nutrients of that runoff water or that effluent water to be used on the crop and disposes of it responsibly, but it also creates some challenges too, and that was with any effluent crop, especially dairy or livestock crop. You've got a lot of solids in that water that have to be dealt with. In a couple stops on the tour, you'll stop and see where that water is split up from the solids, and you do a tertiary treatment. But still, a lot of that ends up in the sprinkler. If you were to walk down the sprinkler, you would see the water coming out, and it would have a little bit of a tint to it, either brown from the wash water or even a little bit of a green tint, symbolizing the manure that's in that water. Some of the problems that creates obviously would be plugging. This is a pressurized system with small orifices to control how much water is applied, and with those small orifices you also end up with potential to plug up emitters and such. If you wanted to look over at this first span, where you can see there's about 5 drops, the first one's got water coming out, you can see it spraying. Well, you can see the second one is plugged, it doesn't have water coming out. It needs to have water coming out, but the materials in the water that come from disposing of that effluent make it difficult. And again, the third one's got water, the fourth one is plugged. I was on a feedlot the other day and saw the worst case scenario for dealing with effluent. This whole sprinkler was plugged from dealing with that effluent. So there's some challenges in getting rid of the effluent responsibly, but in most cases this is what's allowing the dairies to deal with their waste problems using an irrigation system. Talk briefly about the Ogallala Aquifer and the source of all of this water. The Ogallala Aquifer in this area is the primary source of all of the irrigation water. Right here it's probably about 200 feet to water, probably about 400 feet to the bottom of the aquifer, or what's referred to as red bed. So that 200 feet of water in between that, between the top of the water and the bottom, is where you can pump that water from. The method for pumping that water is by sinking, in this case, a pump on a vertical hollow shaft down into the water, and then you use the engine to spin the gearhead and then spin the pump fast, and it creates a lift that'll lift that water to the ground, as well as apply pressure to that water so that it can suitably be used through the irrigation system. The same method has been used in plenty of scenarios and with plenty of different irrigation systems. It's effective for drip irrigation as well as for furrow irrigation. One of the advantages to the pivot system is that you don't really have to create a whole lot of pressure to operate that irrigation system once you get the water up to the ground. The primary drives for these motors in the West Texas area are natural gas engines or electric engines. There's also some diesel engines that are out there, but most of the times the natural gas engines and the electric motors provide the cheapest method for providing that water to the crop. Just so you're familiar with the water costs, the energy that's consumed in lifting and pressurizing that water in this area is the real only cost to that water. Being as it's a right to capture groundwater state in this area, if you can lift that water from the aquifer to the surface, you own that water. Obviously that's created a lot of political pressure in terms of dealing with a declining water situation. That's one of the reasons why you see this dairy using their water in multiple different points around, where it'll be used for wash, it'll be used for drinkers, and then finally land applied to get right back into that system of responsibly using that water.